In C, we have what is known as dynamic memory allocation. The standard library functions we use are malloc, calloc, realloc, and free. Each of these functions have their full definitions listed to the right. So what is dynamic memory allocation exactly? Let's start by understanding static memory allocation. Let's say we create an array of chars that can hold 5 elements. We can then ask the user to put in a specific username. If our friend Bob puts in his name, there is plenty of space for his username, given that it is only 3 characters. But let's say we have a friend with a longer name. If our buddy Richard decides to put in his username, there's clearly not going to be enough space in our statically allocated array. So if we don't know how many characters the username is going to contain at runtime, what's the solution to this problem? The answer is to dynamically allocate memory. Here we have our 4 functions to perform this task. Let's first talk about malloc. Malloc is the most commonly used function for dynamic memory allocation, and we set a void pointer equal to it. This pointer points to the beginning of the allocated memory. Malloc also takes as a parameter the size in bytes that we need for our buffer. Let's say we want a user to give us a certain number of integers and we want to add them all up. We first start by declaring an array pointer on line 5. On line 6, we initialize a few integer values, and on line 7, we initialize our sum to equal 0. On line 8, we then prompt the user to enter a number of elements, after which we use the scanf function to take in that integer. Line 10 is of particular interest and is where we set our integer pointer array equal to our malloc function. We cast malloc as an int pointer and make sure that our buffer is the number of elements multiplied by the size of one integer. Lines 11, 12, and 13 are our fail conditions in case our array pointer is not pointing to anything. Now in this next print statement, we tell the user to enter the amount of integers that they wanted to enter originally. On line 16, we loop through all of the elements that the user gives us and print out the respective element number before each entry. The i+1 allows us to print out the element number instead of the index, and our scanf takes in the element input. To top off our small adding element program, we just need to loop through all of the elements in our dynamically allocated array and sum them up. Alright, last but not least, we use the free keyword to avoid memory leakage. The free function takes the pointer of our buffer and frees memory on the heap in your computer. So now we're ready to compile and run our program with our new malloc knowledge. We compile with the command above, and then we can use the /dynamic memory to actually run our program. So here we have our prompt enter number of elements. If we put in 4, we can enter 2, 4, 6, 8, and get our desired sum of 20 in this case. But let's say we wanted to add a different number of elements. So at runtime, we can put in 6, and our prompt tells us to enter 6 integers. We can then get our desired sum of 21, in this case, thanks to malloc. Let's now take a look at calloc. Calloc stands for contiguous allocation and is similar to malloc, but it initializes all the buffer memory to 0. It also takes 2 parameters instead of 1, the first being the number of elements, and the second being the size of each respective element. In this more involved example, we're looking to create a tic-tac-toe board. We have a print board function that takes in a double pointer, which is a pointer to another pointer. We also have a nested for loop that uses the ith and jth indices to print out the different board elements. Finally, on our line 10, we have a print new line statement that helps us format the output to look how we want to look. In our main function, we have a double int pointer called board. We can then set that double pointer equal to our contiguously allocated memory. This will allow us to get our rows for the tic-tac-toe game. This means we have a double pointer pointing to the beginning of an array of integer pointers. We then have our fail conditions as usual. Alright, so this is a little trippy, but each element in board is an integer pointer, so we can set each int pointer from our first buffer to point to the beginning of their own array of 3 integers. This allows us to create a matrix or 2-dimensional array. Then we can print out our board full of zeros thanks to calloc. So what do you think is going to happen when we compile and run our program? Well, we didn't put anything in our tic-tac-toe board, so it should just print out all zeros like is shown right here. Alright, but what if we actually put something in our board? So if we have our board 1 and then 2, we're going to be putting a 1 in our second row and third column entry. Our last dynamic memory allocation function is realloc, which stands for reallocation. It takes in two parameters similar to calloc. However, realloc just takes in the existing pointer to allocated memory from a malloc function, and then takes in a new size in bytes as well. In this example, let's set up our program with an array pointer, a size, a count number, and our input. We now allocate memory that is the size of just 2 ints, using the malloc function. We can create an infinite loop that takes an integer input. We also add a conditional statement that breaks out of the loop when the input is -1. We then add a conditional statement that increases the size of our buffer every time our count is equal to our size. This means that we can continually allocate more and more space if we need this space for more integers. Alright, let's do a quick recap. Dynamic memory allocation allows us to allocate different amounts of memory at runtime without statically allocating memory in our program. This allows us to create arrays, use data structures such as BSTs that are able to take different amounts of input. We can also build memory buffers, dynamically resize our buffers using realloc, and manage our memory more efficiently. If you found this video helpful, please like and subscribe to support more content just like this.